Ever wonder what holds molecules together? Why some bonds are stronger than others, or why double and triple bonds have their unique properties? It all comes down to sigma and pi bonds. In this video, we're diving into the fascinating world of molecular bonding. Stick around, it's simpler than you think. Let's start with the basics, sigma bonds. These are the first and strongest type of bond formed between atoms. A sigma bond happens when atomic orbitals overlap end to end, creating a strong, direct connection along the bond axis. Every single bond in a molecule, whether it's in hydrogen, methane, or water, is a sigma bond. They're like the backbone of molecular structures, holding everything together tightly. Now, let's talk about pi bonds. These bonds are formed when atomic orbitals overlap side by side. They're not as strong as sigma bonds because the overlap isn't as direct. You'll find pi bonds in double and triple bonds. In a double bond, there's one sigma bond and one pi bond. In a triple bond, like in acetylene, C2H2, there's one sigma bond and two pi bonds. The more pi bonds, the shorter and stronger the overall bond, but they also make the molecule less flexible. So, what's the difference between sigma and pi bonds? Sigma bonds result from end-to-end overlap, making them strong and flexible. Pi bonds come from side-by-side overlap, making them weaker and more rigid. Sigma bonds allow free rotation around the bond axis, but pi bonds lock the structure in place, adding rigidity. That's why single bonds are freely rotatable, but double and triple bonds keep molecules locked in specific shapes. Understanding sigma and pi bonds is essential for explaining the properties of molecules. Ethene's double bond gives it rigidity, making it useful in polymers like plastic. Acetylene's triple bond makes it incredibly strong and energy-rich, perfect for welding torches. So, to recap, sigma bonds are the strong, flexible connections formed by end-to-end overlap. Pi bonds are the weaker, side-by-side overlaps that add rigidity in double and triple bonds. Together, they create the diverse molecular structures that shape the world around us. If you enjoyed this deep dive into molecular bonding, hit that like button, subscribe, and share it with your friends. Let's explore more chemistry magic together. See you in the next video.